rule. Wow, my chart kind of developed itself here, but let's get them in here. If you have, when we did this earlier in the lesson, when you had 2 to the third power, remember that equals 8, 2 to the second power equals 4, 2 to the first power equals 2, and then we just did 2 to the 0 power, and that equals 1. Okay, the next rule we're going to talk about is what do you do when you have a negative exponent? Okay, well, if we just follow the pattern here, the exponents are only going down by 1 every time. So it should hold true that if I'm dividing by 2, going down the list here to get from one spot to the next, we're going to keep that pattern in play. So if I take 1 and I divide it by 2, what do you end up with? Okay, and the magical answer here is if you do it as a decimal, people are going to say, oh, 1 divided by 2 is 0.5. Okay, well, yeah, that'd be true if it was a decimal, but 1 divided by 2 also just equals 1/2. All right, and that's pretty nifty. Now, what if we go down to the next one? What's 2 to the negative second power? Okay, well, if we follow our rule and keep dividing by 2, if you take 0.5 and divide that by 2, you're going to get 0.25, all right, or 1/4. Okay, but what's another way to write 1/4? 1/4 is the same thing as 1/2 to the second power. So we're going to kind of get into that rule today. What do you do when you have a negative exponent, and how is it played? All right, same thing over here. If we look at the rule we did yesterday with the quotient of 2 powers. Yesterday I told you that if the bottom power was bigger, you would do just, all right, x goes in the bottom, so I'm going to do 5 minus 3 is 2. Okay, and then you put a 1 on top because there's nothing left to go on top. Okay, but if we rewrite this and think of this as x to the third over x to the fifth, and we just do the subtraction and just say, oh, it's x to the 3 minus 5 power, that becomes x to the negative second power. All right, so sometimes when you get a negative exponent, you're like, well, what does that mean? Well, what it means is you're going to get 1 over x to the second power. So we're going to talk about that rule. And that's the rule we're developing here today. Okay, so the negative exponent, and I call this the first version, so that's why I have this little 1 over here. All right, there's kind of 2 versions of this rule. The first version basically says this: if you have a to the negative x power, what you want to do is we want to get rid of that negative exponent. Negative exponents are kind of like frowned upon in math. All right, you can use them, and they certainly have their role. Okay, but it's one of those things where it's better to write your answer with a positive exponent. Okay, so if I have a to the negative x power, I can rewrite that as 1 over a to the x power. Okay, and that's essentially the rule. You're essentially gonna. I always think of it as change the side, change the sign. Okay, think change. What are we going to change here? You're going to be changing the side, and you're going to be changing the sign. Okay, so when I say side, what do I mean by that when I say change the side? I'm talking about changing the side of the fraction. So right now, if you think of this as like a to the negative x over 1, I'm going to move it down to the bottom, and then I'm going to change it to a positive x. Okay, so the rule says when a number is raised to a negative exponent, you will move the power to the denominator of a fraction and change the exponent to a positive number. Okay, so if you have like 4 to the negative third power, I'm immediately going to rewrite it as 1 over 4 to the third power. All right, you change the side, you change the sign. So 4 to the third power, if you use a calculator, is just 64. So that's 1 over 4 to the third power. X to the negative 6th power, immediately write it 1 over x to the 6th power. Okay, you move it to change the sign, change the side. Okay, you change it to a positive 6. If I have 4x, all that raised to the negative 1 power, be careful here. It's going to be 1 over, bring the whole parentheses, 4x. Now all of that raised to the positive first power, we change the sign. All right, which anything raised to the first power is just itself, so this just becomes 1 over 4x. All right, so anytime you have that negative exponent going on there, anytime you're dealing with a negative exponent, you're going to change the side that it's currently on, move it to the other side of a fraction, and then make that exponent positive. Okay. One thing I'm going to state here too that I don't have it written on the slide here, but I need you all to remember this is negative exponents don't make your answer negative. Okay, keep that in mind. All right, negative exponents rule number 2. This basically just flips the situation around. What if you have the negative exponent in the bottom of a fraction? Well, if you have a negative exponent in the bottom of the fraction, all you're going to do is you're going to move it up to the top of a fraction and make it positive. So we're still playing the same rule. What are we doing? All right, well, we're going to change. We're still changing the side, and we're still changing the sign. Okay, we're still going to change the side, and we're still going to change the sign. Okay, so the rule as written is when a number in the denominator of a fraction is raised to a negative exponent, you will move the power to the numerator of a fraction and change the exponent to a positive number. All right, so let's look at some examples. If I have 1 over 3 to the negative second power, I'm going to move it to the top and make it a positive, and then just put the 1 on the bottom. 3 to the second power just equals 9, so this just ends up equaling 9. Okay, 3 over x to the fourth power. Okay, 3 stays put. Okay, 3 doesn't have any exponents. We're just going to move the x to the fourth up top. So it moves to the top side of the fraction. All right, it becomes a positive 4. All right, and then on the bottom you would have just a 1 because nothing's left there. But anything divided by 1 just is the anything, so this just becomes 3x to the fourth power. And last but not least, if you have something like 1 over 5x to the negative second power, again, move the whole parentheses, 5x to the positive second power now, all that divided by 1. All right, and then you'd want to distribute the 2 here. This would just become 5 squared times x squared over 1, and then that just becomes 25x to the second power, because 5 squared is 25. Okay, so negative exponent on the bottom, move it on up to the top and make it positive. If you have a negative exponent on the top, move it down to the bottom and make it positive. Change the side, change the sign. All right, so some quick examples. Let's throw it in with some of the other rules. Here you have x to the negative third times x to the fourth times x to the negative ninth. First thing I want to do is add those exponents because this is the power of a product of 3 powers. So if we put this all together, it's x to the negative third plus 4 plus the negative 9. All right, so when you add those together, negative 3 plus 4 is 1. 1 plus negative 9 is negative 8. So I have x to the negative 8th power. Since that's a negative exponent at the top, we're going to move it to the bottom and it becomes 1 over x to the positive 8th power. Second example, kind of like the rules we were doing yesterday. Again, don't panic here. All right, we do have some negative exponents, but what I would just tell you to do is start by looking at it and saying, all right, what's bigger, 8 or negative 2? Which power is bigger? 8 is bigger than negative 2. Think of it like a temperature. Which side is warmer? 8 degrees is warmer than negative 2 degrees. All right, so now we're just going to subtract. I know my x is going to end up on the bottom, and we're just going to do 8 minus negative 2. Okay, so you could do that, or you could just think I have x to the negative second on top. I'm going to bring 2 of them to the bottom. So it works either way, but if you do 8 minus negative 2, you're going to get a positive 10. Okay, that's essentially what's going on there with the rule. And then the y's, 5 is warmer than negative 1. So I'm going to get y to the 6th power. All right, if I kind of slow that down, I kind of blast it through that. Let me just kind of redo that. Hang on one second. Let's erase this for a second. Hang on, a little bit instant replay in slow motion. If you had to rewrite this, I would think of it like this. All right, on the bottom, 8's bigger than negative 2, so you're doing x to the 8 minus negative 2. Okay, and then on the top, you're doing y to the 5 minus negative 1. Okay, so in cleaning that all up, 5 minus negative 1 gives you y to the 6th. Okay, if there's a minus sign, you change the sign. And then 8 minus negative 2 becomes 8 plus 2, so that's why it becomes x to the 10th power. All right. One more example here, something like this. What if you have x to the 4th over y to the negative 2, all of that raised to the negative 3? I would probably, on a problem like this, is since the bases are different here, I'm just going to multiply negative 3 to both exponents on the inside here. So that's going to give me x to the negative 12th power divided by y to the positive 6th power. All right, because negative 2 times negative 3 is positive 6, and 4 times negative 3 is negative 12. And then to finish this off, here's what you want to observe is you have an x to the negative 12th power. I need to move that to the other side of the fraction. Change the side, change the sign. So the y to the 6th is going to pick up a new roommate. All right, it's going to get x to the 12th is going to come down to the bottom. You move the x to the bottom, you make the 12 a positive 12, and then since nothing is left on top, we put a 1 there. So your answer would be 1 over y to the 6th times x to the 12th. Here's something you might see in Delta Math. Write the following expression without negative exponents and without parentheses. All right, so here I see negative 2x to the negative 1 power. First thing I would do is think, all right, it's got a negative 1 on the outside, so I'm going to put it on the bottom. So negative 2x stays inside the parentheses, and now it's raised to the 1st power. And then remember that anything raised to the first power is just going to be the anything, so you're just left with 1 over negative 2x.